So once we draw and label our diagram, we use the fact that we don't know any of the angles to figure out that we need to use the law of cosines to begin. So we have 4 squared equals 5 squared plus 6 squared minus 2 times 5 times 6 times the cosine of angle A, which is the angle we've chosen to solve for, which gives us 16 is equal to 61 minus 60 times the cosine of A. We can subtract 61 from both sides of the equation, which will give us negative 44 is equal to negative 60 times the cosine of A. We can then divide both sides of that equation by negative 60, and that will give us negative 44 over negative 60 being equal to the cosine of A. If we take the arc cosine or inverse cosine of both sides, we get that A, the angle, is equal to the inverse cosine of 44 over 66, or approximately 42.8 degrees, which we can add to our diagram. Now that we know an angle, we can use the law of sines to find another angle because we have all the sides. So we can say that the sine of 42.8 over its opposite side, 4, is equal to the sine of angle B over its opposite side, 5. And we can start out by just multiplying both sides of the equation by 5, which is going to give us the sine of B being equal to 5 times the sine of 42.8 all over 4. And here we can simplify the right side to the sine of B is equal to 0.849. And now if we apply the arc sine to both sides, we'll have B, the angle, is equal to the arc sine or inverse sine of 0.849, which is approximately 58.2 degrees, which we can then add into our diagram. And to find our final angle, we could use the law of sines again, or we can just make use of the fact that the interior angles of a triangle have to add up to 180. So we can take 180 degrees, subtract our other two angles, and get our final answer, which is that the measure of angle C is equal to 79 degrees.